Today we'll talk about the geometric distribution. In the geometric distribution, we're modeling a situation in which we're constantly trying something with the same probability to have a success in every trial. However, in K trials totally, there's only one successful trial at the end of the experiment and K minus 1 failures. Let's start with a simple example. Jack decides to shoot hoops from afar. The chance Jack will succeed in doing this is 7.5%. What's the chance Jack will have a successful trial in his 11th attempt? Well, the meaning of this is that Jack will have 10 failures prior to his success and then a successful trial. That's the probability for this. That'll be 1 minus 0.075 to the power of 10, which are the 10 failures, times 0.5%, 0.075, which in total will be 0.03439, which is 3.439% totally. Now let's assume Jack is trying to shoot from even further distance, and thus his chance of having a successful trial is just 3.1%. What's the chance he'll have 22 failures before a successful attempt? Well, in this case, we're talking about the 23rd time, which will be a successful time, which means 1 minus 0.031 to the power of 22 times 0.031 for the last successful attempt. Altogether, it's 1.55%. Now, in generally, we can say that the probability function is infinite. The results 1, 2, 3, 4, 5, 6, and so on represent the first and only success in the sequence of trial, success that finishes the sequence of failures or failures. That's the general format of the distribution for have a successful trial at the kth trial. That means 1 minus p to the power of k minus 1, that stands for k minus 1 failures, times p for the last successful trial. The probability function for this would be as shown here. We have 1, 2, 3, 4, 5, and so on. And accordingly, we have the probabilities. For the first attempt, we have 0 failures. So that'll be 1 minus p to the power of 0 times p. The second, for 2 attempts altogether, we have p times 1 minus p. P stands for success, 1 minus p stands for failure, and so on and so forth. The expected value of this function would be 1 over p. The variance would be 1 minus p over p squared, and the standard deviation would be the square root of the function of the variance. And for Jack, we had a success rate of 7.5%. The expected value would be 13.33, which is actually for the 13.33 time Jack will have a successful trial. The variance would be 164.44, and the standard deviation would be 12.8236. Hope this was helpful for you. Hope you have learned. Have a good day and see you in the next session.